Hello everyone! Do you know why video calls are so exhausting? It's because your brain keeps reminding you this is just an image on a screen. Now, imagine sitting down at a table and seeing the other person appear in front of you in full size in 3D. You can see them breathing, catch the light in their eyes, even notice the texture of their shirt, and you don't need VR goggles to do it. Google has developed Project Starline, a system that captures not just video, but an entire light field. What does that mean? Dozens of cameras record every photon reflected off the person in front of them. AI processes terabytes of data faster than it takes you to say hello. But the real trick is the screen, which displays a different image to each of your eyes with no need for 3D glasses. HP is already building the first devices that use this technology. The price? For now, it's in the same ballpark as a decent car. But remember, early cell phones used to cost as much as a motorcycle. Give it 5 years and you'll be having breakfast at home with your parents living in another city. But Google isn't the only one rethinking how we experience digital content. How many times have you looked at an old photo and thought, I wish I could see what happens next? Maybe your grandmother's frozen mid-wave. Was she saying goodbye to someone? Your grandfather is just beginning to smile. What would he look like a second later? The creators of Midjourney, the most popular image generation AI, can now show you exactly that, the what's next. Any still photo can be transformed into a living, moving video. How does it work? The AI analyzes billions of details in a single frame, such as shadows, lighting, and perspective, and then predicts how each object would move in 3D. Want the ocean in a painting to start rippling? Done. Want a painted bird to take flight? No problem. And the system actually understands physics. Hair moves realistically, fabric drapes correctly, and water flows like real. Here's the part that's hard to believe. It costs 25 times less than any existing technology. A single second of video is as cheap to generate as a still image. Directors are already using it for storyboarding. Historians are bringing old photos to life, and regular people are turning family albums into short films. What's next? The company promises real-time generation. You describe a scene and it materializes right in front of you. Imagine video games where every environment is unique and shaped by your input. But while we're busy animating old photographs, artificial intelligence is working on something even more important. Do you know how long it typically takes to develop a new drug? Anywhere from 10 to 15 years, apart from the price of about $1 billion. Now brace yourself. A company called In Silico Medicine developed treatment for a rare lung disease in just 18 months, spending 10 times less. How? They trained artificial intelligence to be a brilliant chemist. Here's how it works. The AI combs through millions of scientific papers, studies the structure of healthy and diseased cells, and figures out which kind of molecule could fix what's gone wrong. But the coolest part is that it doesn't just test existing compounds, but invents brand new ones. It's like asking a computer not to find the right part in a warehouse, but to design it from scratch and 3D print it on the spot. Another company, Recursion, has taken it even further. They've photographed cells and collected 65 petabytes of data. That's more than all of YouTube. Their AI can detect cellular changes invisible to the human eye. 3 of their drugs have already advanced to human trials. One of them has received orphan status, reserved for treatments of rare diseases that big pharmaceutical companies tend to ignore because they aren't profitable. So what does this mean for the rest of us? It means treatments for Alzheimer's, rare cancers, and genetic disorders could be just a few years away instead of generations. And more importantly, they won't be priced for millionaires. We're talking about medications affordable under an average health insurance plan. The future of medicine has already arrived. Most people just don't realize it yet. And while AI is saving lives in the lab, other scientists are helping people regain what once seemed gone forever. Okay, look, you're probably thinking, great, another high-tech prosthetic. I've seen hundreds of these already. And yes, prosthetics are getting better all the time. But here's the twist. The guy using this one can feel when he steps on a Lego. He feels it. He doesn't just see it and avoid it, he senses the sharp edges of the plastic through his titanium leg. His brain actually screams ouch, even though there's no living tissue there. How is that even possible? The secret lies in a surgical breakthrough called AMI. During the amputation, surgeons preserve and rewire the nerves and muscles so they can keep talking to each other like they would in a healthy limb. Then, they implant a titanium rod into the bone with 16 electrodes that read the muscle signals. Imagine this, you think about moving, your muscles contract, the electrodes pick it up, and the prosthetic moves exactly the way you intended. But here's what's truly mind-blowing: feedback. Sensors in the prosthetic send signals back to the nervous system. The brain gets updates on the leg's position, pressure, and even the texture of the surface it's stepping on. People with this kind of prosthesis climb stairs 40% faster than those using conventional ones. They avoid obstacles naturally without even thinking about it. One participant in the clinical trial said, "For the first time in 10 years since my amputation, I don't think about how to walk, I just walk." The technology is already in the final stages of approval. In 5 years, it could be the new standard. We're entering an era where losing a limb doesn't mean losing your future. But do you know what's even more impressive than restoring lost abilities? Creating something nature never gave us. What's the smallest thing you can see? A speck of dust? A grain of sand? What if I told you that scientists are now printing structures 1,000,000 times smaller than that? Boston Microfabrication is creating components just 2 microns across. That's 50 times thinner than a human hair. And that's just the beginning. At the University of Oldenburg, researchers have gone even further. They're printing with individual atoms. How? They take a glass tube, heat it with a laser, and stretch it until the opening is so tiny that only a single molecule can pass through. Then, using electrochemistry, they guide metal ions through a solution to an electrode, where they solidify atom by atom. So why go to these extremes? Picture a processor with transistors made of just a few atoms, or a medical implant the size of a bacterium, traveling through the bloodstream to repair damaged cells. Experts are already printing endoscopes with channels thinner than a hair, chips for analyzing individual cells, and connectors for quantum computers. Carbon 3D has turned the technology into an art form. Their printers use UV light to solidify liquid resin, building objects layer by layer. And they're fast, up to 100 times faster than conventional 3D printing. They're already producing parts for Boeing, dental implants, and even Adidas sneaker soles, all printed at a molecular level. The future of manufacturing isn't factories, it's printers. And while some are printing at the scale of atoms, others have figured out how to generate electricity from nothing. Well, almost nothing. Here's a trick question. What do a river flowing into the sea and a battery have in common? You might say nothing, but the French company Switch Energy disagrees. They use fresh water, salt water, and a special membrane to generate electricity. No turbines, no steam, no solar panels, just water with different salt levels, and it runs 24/7. The physics behind it is elegantly simple. When fresh water meets seawater, salt ions naturally try to balance out. Sweech developed a membrane just a few molecules thick that only allows either positive or negative ions to pass through. That creates a flow of charged particles. In other words, an electric current. Just 1 cubic meter of fresh water mixed with seawater generates as much energy as the same amount of water falling from a dam 270 meters high. The first facility is already under construction on the Rhône River in France. Its output will reach 5 megawatts, which is enough to power a small city, while the system efficiency should be a staggering 90%, better than any thermal power plant. And the best part? No emissions, no noise, and no harm to fish. In fact, the desalinated water that remains can even be used for irrigation. The potential is enormous. Wherever rivers meet the sea, this tech could generate terawatts of energy. It's like building an invisible hydroelectric plant without a dam. Norway's already planning to supply a third of its power this way by 2030. And speaking of closed-loop systems, that trend is catching on in places you wouldn't expect. Take strawberries, for example. You know what's frustrating about out-of-season strawberries from the supermarket? They look great, but taste like cardboard because they've traveled 5,000 kilometers and are pumped full of preservatives. Dyson, the vacuum company, decided enough is enough. They've built a greenhouse the size of 20 football fields where strawberries grow year-round and taste like fresh summer berries from a garden. And here's where it gets interesting. The greenhouse is heated by cow manure. More precisely, it runs on biogas produced through anaerobic digestion of agricultural waste from nearby farms. In this process, bacteria break down the manure without oxygen, generating methane, which is then burned in turbines to produce both electricity and heat. The leftover material, called digestate, is used as fertilizer. It's a perfect closed cycle. Zero waste, zero emissions. Now, here are some numbers that'll make you dizzy. 10 hectares of greenhouses, 1,456 strawberry rows, and 1.2 million plants. Each year, they produce 1,250 tons of berries, which is about 50 truckloads. The temperature is controlled by a computer to within 1/10 of a degree. Rainwater from the roof is collected in a reservoir and used for irrigation. Even the beds sway back and forth during the day to expose the plants to more light, boosting yields by 15%. Already in 2025, Brits were able to enjoy local strawberries in January. And experts are also working on robot harvesters and LED lighting to grow fruit even during polar nights. The future of agriculture isn't endless fields, but smart food factories. But high-tech greenhouses are just one half of the agricultural revolution. Wait, don't skip this part. Yes, we're going to talk about fertilizer, but it's actually fascinating. Do you know where food for half of the planet comes from? Nitrogen-based fertilizers. And do you know how they're made? By burning massive amounts of gas at 500 degrees Celsius. Fertilizer production consumes 2% of the world's total energy. But two companies, Pivot Bio and Green Lightning, want to change the system. Pivot Bio took the biohacker route. They found bacteria that can turn nitrogen from the air into nutrients for plants. The problem is that in nature, these microbes are lazy and inefficient. But experts found a solution: reprogramming their genetic code. Now, these hard-working microbes live on the roots of corn and pump nitrogen around the clock. No fertilizer runoff into rivers, no dead zones in the ocean, and crop yields go up by 14% with zero synthetic fertilizer. Green Lightning took more of a Tesla approach. They created lightning inside a sealed chamber. Electric discharges split nitrogen molecules in the air, like during a thunderstorm. The result is liquid fertilizer produced right on the farm. Picture this: a garage-sized machine in the farmer's yard making fertilizer from nothing but air and water. No middleman and no chemicals. Both technologies are already being used on thousands of farms across the US. By 2030, they could replace a third of all synthetic fertilizers. This isn't just a new product, but a breakthrough as important as the tractor. And these revolutions aren't just happening in the fields, but in how we get from point A to B. Speaking of breakthroughs, remember when Elon Musk promised plane-speed trains back in 2013? Everyone thought it was just another pipe dream. Fast forward to 2019, and a group of students in Munich got a test capsule up to 463 km per hour. Virgin Hyperloop has already carried passengers, granted at only 172 km per hour, but that's just the beginning. The idea is surprisingly simple. Take a giant tube, pump out nearly all the air until it's down to 1,000th of the normal atmospheric pressure, and launch a capsule inside it on a magnetic cushion. With no rail friction and no air resistance, the capsule floats and glides. The result? A theoretical top speed of 1,200 km per hour. That's Los Angeles to San Francisco in half an hour. Of course, the devil's in the details. How do you maintain a vacuum over hundreds of kilometers? How do you handle turns at that speed? What's the emergency plan if something goes wrong mid-route? Engineers are pondering those questions, and they're making real progress. Heart Hyperloop has already demonstrated a track switching system with no moving parts. The pod itself chooses the direction using a magnetic field. Critics might say, too expensive, too dangerous, never gonna happen. But do you know what people said about the first aeroplanes? The exact same thing. The European Commission has already published technical standards for Hyperloop systems. The first commercial lines are expected by 2030. Do you think at least one will be up and running by then? And while Hyperloop is still battling doubts here on the ground, up in the skies, there are already technologies flying that have left skeptics speechless. Have you ever heard a sonic boom from a supersonic jet? It sounds like a giant clapping his hands right above your house. Windows rattle, dogs howl, and people look up in panic. That's why the Concorde only reached supersonic speeds over the ocean. But Lockheed Martin said, "Hold my beer," and set out to build a jet that, even at supersonic speed, would sound more like a car door closing. The result is the X-59. It's 30 meters long and looks like a needle. The nose alone makes up a third of the fuselage. Why? To spread out the shockwave. Instead of a single loud boom, the shape creates a series of smaller, softer waves. The engine is mounted on top. The air intake is built into the fuselage, and the wings and tail are positioned to cancel out the pressure waves. As a result, it produces just 75 decibels, compared to the Concorde's 110. That's the difference between a gunshot and a conversation. But here's the crazy part. The pilot can't see where they're going. The massive nose blocks the view entirely. Instead of a windshield, the cockpit uses a 4K camera and a screen. It's like flying in a flight simulator, except you're 16 kilometers up in the air, moving at 1,500 kilometers per hour. The first test flight is scheduled for 2025. The plan's pretty bold. Fly over US cities, monitor public reactions, and prove to regulators that supersonic flight can be quiet. If they pull it off, by 2035 we could be flying from New York to London in 3 hours, and the people below won't hear a thing. But while we're getting ready to fly fast and silent through the atmosphere, some are looking even farther into deep space. And pretty soon, in 2026, a mission is set to launch from the spaceport in French Guiana, one that might answer humanity's biggest question: are we alone in the universe? PLATO is a huge space telescope, equipped with 26 cameras, reaching a resolution of 81 megapixels each. Together, they create a 2 billion pixel image, which is actually a record for space missions. How do scientists find planets around distant stars? It's brilliantly simple. They check if the star flickers. When a planet passes in front of a star, its brightness drops by fractions of a percent. PLATO will stare at 200,000 stars at once, taking a photo every 25 seconds for 2 years straight. It's like filming a time-lapse of the entire sky. But here's the mind-blowing part. PLATO won't just spot planets, it'll find planets in the habitable zone. Not too hot, not too cold, just right for liquid water. Even more impressive, it'll measure their size with a 3% accuracy, and their mass within a 10%, and even their age. We'll find out if they have continents, oceans, maybe even signs of life in their atmospheres. Early missions found thousands of exoplanets, but most of them were hot Jupiters orbiting red dwarfs. PLATO is focused on Sun-like stars and rocky Earth-like planets. If there's intelligent life anywhere within 1,000 light-years, we'll find it. Or finally realize just how unique we really are. Still, before we go looking for life out there, we should probably clean up our own orbit. Do you know what's flying around Earth right now? 130 million pieces of space junk. From spent rocket stages to lost bolts, each one is a potential bullet, traveling at 28,000 kilometers per hour. A single screw can turn $1 billion satellite into a heap of scrap metal. But the company Cal Morris asked, what if we built a space cleaning robot with the capabilities of a gecko? Reach is a robotic arm that uses gecko feet technology to grab objects in space. No magnets, no harpoons, no nets, just microscopic hairs that stick to any surface thanks to the van der Waals forces. Press down and it holds, let go and it will leave no trace. In November 2024, Reach was sent to the ISS. Astronauts, including Sunita Williams and Don Pettit, ran 172 capture cycles with different objects. The result? 100% success. The test video became the most viewed post on the ISS's Instagram with 23 million views. People were stunned. A gecko robot catching floating objects in zero gravity like candy. But this isn't just a cool gadget. Reach can remove dangerous debris from orbit, move satellites into new positions, and even repair spacecraft. Cal Morris became the first private company to successfully capture an object in space. Thanks to them, our orbit is getting cleaner, and we're one step closer to the trash-collecting spacecraft of science fiction. So that's it. 12 technologies that are already changing the world. From holographic video calls to space gecko robots. From prosthetics that can feel to AI that designs medicine. 10 years ago, each of these sounded impossible. But what do they have in common? They were created by people who didn't believe in the word impossible. People who looked at a problem and said, what if? The world is changing faster than ever. Today's breakthroughs will be tomorrow's everyday life. And the best part is that the next great idea could come from anyone, maybe even you. So next time someone says, that's science fiction, remember this video. The future isn't waiting, it's already happening. See you in the future. Or maybe we're already in it.